Schematics can look intimidating, but what if you could actually hear them come to life? In this series, I'm taking real pedal schematics and building them step by step on a breadboard so you can see exactly how they turn into sound. Today, we're creating the Little Angel chorus built around the PT2399 and way simpler than you might think. Let's turn this schematic into an actual chorus effect. Welcome back to another schematic to breadboard series. Today we're doing a chorus effect using the PT2399 chip. And just like the other videos in this series, we're going to go section by section. So without any more delay, let's start with our power section. So in the power section, this is a little bit more involved than the other ones that we've done so far. It has a voltage regulator, as well as two separate voltage dividers. This one uses two of the same value resistors to give us half the voltage, and this one uses two different value resistors to give us about 3 volts right here. So we have VC, VB, and then over here we have 5 volts, which is given to us by our voltage regulator. And we can see VC is used over here in our second op-amp stage. VB is used over here in our first op-amp stage, and of course our 5 volts is used to power our PT2399. So I'm going to start by adding our voltage regulator, our 100 nanofarad cap, and our 47U electrolytic cap onto the breadboard to give us our 5 volt reference. Here is our little voltage regulator. The middle leg goes to ground, this right leg goes to our 9 volt power, and then this leg is going to give us our 5 volts. So I'm going to arrange it in the breadboard just like this, and I had to twist the legs to match the power and ground rail on my breadboard. And if you have to do that as well, just make sure when you twist them that those legs are not touching each other, because that will create a short. Based on the schematic, I also need to add a 100 nanofarad capacitor in the same row as our 5 volt output pin, as well as a 47U electrolytic capacitor in that same row, making sure that the negative leg or the short leg goes into the ground rail. The next thing I'm going to add is this diode right here into our power rail, as well as this 100U electrolytic cap between our power and ground. So I'm going to add our diode across power and ground like this, making sure that the stripe is in the positive side. I'm going to add our 100U electrolytic cap in a very similar fashion, where our negative leg is in the ground rail. And then finally, I'm going to add this 100 nanofarad cap across power and ground like this. Moving from the right to left now, I need to power our op-amp, and that means pin number 4 gets sent to ground, and our pin number 8 is connected to the 9 volt power. So here's our op-amp right here. Pin number 4 is in this row right here, and pin number 8 is in this row. So I'm just going to use 2 jumpers to add power to pin number 8, and I'm going to connect pin number 4 to ground. So this row is going to ground, and then this row is going to our 9 volt power. Next, I'm going to create this voltage divider with the two 10K resistors, and then this 10U cap to stabilize the power, and this goes to ground as well. So I'm going to grab my two 10K resistors, and this voltage is used by our first op-amp stage, so I'm going to add it a little bit closer to our op-amp. And then our 10U cap to ground, making sure that the short leg goes into our ground rail. And then one 10K resistor is coming from our ground rail, and the other is coming from our power rail. And then all of these components are touching each other in the same row. And then finally, I need to create this last voltage divider right here. It is a 100K resistor and a 47K resistor. Right where they meet is going to give us our VC, which is around 3 volts. And this is used by our second op-amp stage. So I'm going to add it on this side down here. This should conclude our power section. And now I'm going to go all the way up top here to where our guitar input enters into the circuit. And I'm going to add this 1 meg resistor that gets pulled down to ground. So I'm going to add a wire for our guitar input. And then I'm going to grab a 1 meg resistor And in that same row where my guitar input is, I'm going to add this 1 meg resistor getting pulled down to ground. And then also touching our guitar input, we have a 100 nanofarad cap with a 470k resistor in series touching our inverting pin of our op amp, which is pin number 2. So I have this 100 N cap, which is going to be touching our guitar input. And then I put this leg in a row where there's no connections. And then from the 100 nanofarad cap, I'm going to go into a 470k resistor into the inverting pin number 2 of our op amp. So this leg right here is in the row touching our pin number 2. Looking back at this schematic, I now need to connect from our non-inverting pin number 3, connect to the 330k resistor to our VB, which if we remember was created down here with the 10k resistors. So I'm going to grab my 330k and I'm going to come from this row right here, which is our 4.5 volt VB, and I'm going to drop it into this row right here where my pin number 3 is. The next thing I'm going to do is connect a 1 meg resistor between pins 2 and 1. So here's my 1 meg resistor, and then between pins 2 and 1, actually I'm going to put it up here. So one leg is touching pin 2 and the other leg is touching pin 1. The next thing I'm going to do is connect a 10k resistor to pin number 1. And I'm going to have that 10k resistor come somewhere over here. Actually, what I'm going to do is I'm going to take a jumper, and I have a couple more connections I have to make to pin number 1, and I'm running out of room over here. So I'm going to take this jumper and jump it over here. So now I have this whole row over here, which I can use to connect to pin number 1. So coming off of this jumper right here, I'm going to take a 10k resistor and do something like this. So one leg is touching this jumper, which is touching pin 1, and then I drop this leg into a new row over here. And then also touching pin number 1, I have this 100 nanofarad cap in series with a 10k resistor. So I have my 100 nanofarad cap also touching this jumper right here, making sure that this leg is in a new row that is not touching this 10k resistor. And then I'm going to take another 10k resistor and I'm going to put it after my 100 nanofarad cap. So just like that, this 10k resistor is touching the right leg of my 100 NF cap, which is then going into pin number 1. And then back here, I have my 10k resistor that is going to be connected to our output cap over here. So I'm going to connect a 100 nanofarad cap to this 10k resistor, and this will be touching our output. Getting to the end of my breadboard over here, so I'm actually going to put my 100 nanofarad cap over here, closer to the output, and I'm going to take a jumper cable and jump from over here to this 100 nanofarad cap. And then I'm going to take another jumper. Then this jumper will be connected to the left leg, connected to my output. So I've just made this connection, and then the output is taken from this side of the 100N cap, just like this. And we still have these connections to make, but that will come later on. So we're feeling good about this first op amp stage. I'm now going to move on to the second op amp stage right here. And the first thing that we're going to do is connect our VC to pin number 5. And if we remember, VC was created with the 47k resistor and the 100k resistor, and that goes into pin number 5. So over here is where I get my VC, and I'm just going to take a jumper and go straight into pin number 5, just like this. I'm now going to take a 220k resistor, and this goes in between pins 5 and 7. So my resistor will go one leg in pin 5, and the other leg will be into pin 7. And then between pins 6 and 7, I have a 10 nanofarad capacitor. So I'll put that in the back right there. One leg is in the row with pin 6, and the other leg is in the row with pin 7. And then coming off of pin 6, I have another 220k resistor going into the lug number 3 of our speed potentiometer. And then also coming off of pin 7, we have a 4.7K resistor going into the wiper lug of our speed potentiometer. So I'm going to start by putting our potentiometer on the breadboard, and then we can make those connections. So here is my linear 100K potentiometer, and we're going to make this 220K resistor between pin 6 and our lug number 3. So I'm going to find pin 6 on my Opamp. I'm going to drop one leg into that row, and then the other leg is going to be going into lug number 3, like that. And then coming off of pin number 7, I have a 4.7K resistor going into the wiper lug or lug number 2 of our speed potentiometer. So I'm going to try to maneuver this jumper wire out of the way just a little bit. So then coming off of pin 7, I have this 4.7K resistor going into our wiper lug. Just making sure that that is in the right row there. Next, I have this 10U electrolytic capacitor coming from lug number 3 going to ground, making sure that the positive leg is touching lug number 3 and the negative leg is going to ground. And to do this a little bit easier, I'm actually going to move this resistor up one row, so I have enough room to drop my cap into here, like that. So both the positive leg of the cap and this right leg of our 220K resistor are touching lug number 3. And then also touching lug number 3, there's a 10UF electrolytic cap going into a linear 500K potentiometer that is used to control the depth. So I'm going to use a jumper to jump into this cap, which goes into this depth potentiometer. So I'm going to start by adding that potentiometer onto my breadboard so I know where to make these connections. And then, like I said, I'm going to jump off of pin 3. So in this row with pin 3, I'm just going to take this jumper and I'm going to place it in this row over here close to my potentiometer, but not touching any of the other components. And then I'm going to take another 10UF electrolytic cap, making sure that the positive leg or the long leg is touching the wiper of our 500K potentiometer. So something just like that should be good. So that should conclude it for this second part of our op-amp right here. And we do have this connection still that goes to our PT399, but I will make this connection a little bit later when I get over to this section. So we just have to come back to this in just a few minutes. But now we're just going to go ahead and start wiring up our PT2399. And we're going to start over here by connecting our analog ground and our digital ground together. And then taking a jumper and going from our pin number 4 into ground. And one thing that I want to really quickly mention about this schematic in particular is these pin numbers do not match their like physical location. And I believe they did this for the sake of making the schematic a little bit more clean. So just make sure you're going based off the pin number and not the actual location on this chip. So I'm going to go ahead and connect pins 3 and 4 together, just like this. And then coming off of pin 4, I'm going to go into ground. So pin 4 is jumped into ground. And then the next thing that I'm going to do is connect a 100 nanofarad capacitor between pins 4 and 8, as well as between pins 4 and 7. So one 100 nanofarad capacitor goes between pins 1 and 8, and another one goes between pins 4 and 7, just like that. The next thing I'm going to do is connect a 2.2K resistor from pin 6 into ground. So I'm going to find my pin number 6, which is right here in this row, and I'm going to go to ground like that. And then I'm also going to come off of pin number 6 and add this 100 ohm resistor, which is going to go into the collector of our transistor here. So I'm first going to add our transistor onto the breadboard. And right here we have an emitter leg, a base leg, and a collector leg. And looking at the schematic, this 100 ohm resistor goes into the collector leg of our transistor, coming off of pin number 6. I'm going to drop our resistor into pin number 6 and then place the other leg in this row where the collector is. I'm then going to connect the emitter to ground and then add this 47U electrolytic capacitor between the base and the emitter as well. So I'm going to add this electrolytic cap between the base and the emitter, making sure that the negative leg is touching the emitter. And then I'm going to take a jumper and go from our ground into that same row. I'm now going to connect our 5-volt reference from our voltage regulator into pin number 1. So I'm going to take my jumper and then drop this into pin number 1. Also coming out of pin number 1, we have a 68K resistor and a 1N4148 diode going to the base of our transistor. So I'm going to take my 68K resistor right here, and I know that it's going to be connected to pin 1. So I'm going to connect one leg to pin 1, and this leg will just be over here in this new row where there's no connections. Then I'm also going to take my diode, making sure that the little black line is also touching pin number 1. I'm going to drop it in the same 2 rows. So this row is touching pin 1. This row is the diode and the 68K resistor touching. And then I'm going to take another jumper and I'm going to jump this into the base of our transistor. So the leg of the resistor and the leg of the diode are essentially connected to the base of this transistor. Now coming off of the base of this transistor, I'm going to add this 10UF electrolytic cap, and I'm going to just place the negative leg, and I'm just going to place the negative leg in a new row where there's no existing connections right now. And then if we look at our schematic, we're going to want this cap connected to the lug number 3 of our depth potentiometer. So I'm going to use a jumper to do that. So placing this jumper in the same row as that electrolytic cap's negative leg, I'm going to take it and I'm going to jump into lug number 3 of our depth potentiometer right here. Before moving on to the other side of our PT2399, I do have to make this connection right here, which is a 33K resistor from pin number 2 going into the same lug number 3 of our depth potentiometer. So I'm going to have to use another jumper, but coming out of pin number 2, I'm going to add this 33K resistor. So it's connected to pin 2 there, and then I just drop the other leg in a new row. And then by using another jumper, I can connect it to lug number 3 of our depth potentiometer. Moving over to the other side now, I'm going to add a 10 nanofarad capacitor between pins 9 and 10, as well as 11 and 12. So between pins 9 and 10, and then again between 11 and 12. And then I'm going to add a 1N capacitor between pins 13 and 14, and a 3.3N capacitor between pins 15 and 16. So 1N between 14 and 15, and a 3.3N between 15 and 16. Now it's time to dust off your 10K resistors because we have a lot of them coming up here in the schematic. So the first 10K resistor is going to be coming off of pin number 12. So right here is pin number 12, and I'm going to just add it to the breadboard like this. So coming out of pin number 12 here, and then dropping that leg into a new row. And then the next 10K resistor is going to be coming off of pin number 13, and then landing in that same row as the first 10K resistor. And then finally, we have another 10K resistor coming off of pin 14, landing in that same row as well. So all 3 of those resistors are in the same row here. One is going to 14, one is going to 13, and one is going to pin 12. Now we're going to add 2 more 10K resistors coming off of pin 15 and pin 16. And these are going to match up with this 10K resistor that we added over here on our breadboard. So another 10K resistor coming off of pin 15. And then another 10K resistor coming off of pin 16. Making sure to land these in the same row, different than these 10K resistors. And then now I'm going to need another jumper wire to connect these two 10K resistors to this 10K resistor over here. So now we have made that connection. We're now going to add a final 10K resistor coming off of pin 14, which is going to be going to a 100 nanofarad capacitor in series and then getting pulled down to ground by this 100K resistor. And then we're also going to have to make this connection to this 100 nanofarad capacitor that we put right here earlier in the build. So coming off of pin 14 now, I'm going to take a jumper to make this a little bit more clean. I just put one side into pin 14 and I'll drop into a new row where there's no connections. And then I'm going to place a 10K resistor, making sure that it is in the same row as that jumper. And then I'm going to add a 100 nanofarad capacitor in series. So it's going to be touching that 10K resistor. And then finally, I'm going to add a 100K resistor to ground coming off of the right leg of that capacitor. Now, the only thing that we have to do is connect this 100 nanofarad capacitor to this 100 nanofarad capacitor, which is touching our guitar signal out. So one final jumper here. I'll use a small one. So I'm going to jump across the breadboard, just like that. So you can see here the row with the 100K resistor and the right leg of our cap is getting jumped into the left leg of our capacitor back here, which is touching our guitar output. And I've gone ahead and run out of components, which means we're done with the circuit. So I'm going to go ahead and test this now and come back and let you know if there's any adjustments or tweaks that you need to make, or if I made any mistakes along the way. I'll let you know in just a second. So I've just gone ahead and tested the circuit and everything is working the way that it should. I really hope you enjoyed this build and are enjoying this series. As always, leave your suggestions for more builds like this down below. And I think the only thing left to do now is to hear it in action.